Hi everyone, in this video we're going to go through past VCE exams focusing on circular functions. You'll notice at the top of each question I'll say where it has come from. So this very first question we're going to do is from last year's exam 1. Okay, so exam 1, remember, is tech-free. You're also not allowed your bound reference. You will be given a formula sheet, so make sure you're familiar with that formula sheet. So whenever you're doing exam 1 questions, before you refer to your bound reference, refer to the formula sheet. So just so you're familiar with it. Exam 1 is also only 1 hour long. So you really need to just spend time on questions that you do know how to answer, and any that you are a bit unsure of, you need to leave it until the end. Okay, so don't go wasting time. You don't have time to waste. So you've got 1 hour. During your 15 minutes reading time, that's when you should be deciding which questions you can do, and you focus on them first. So once you can start writing, maybe even if you jot them down, you can write them on your formula sheet because you can detach your formula sheet. But just doing questions you can do and just going back later when you've got time, or if you've got time to do those questions you might struggle with. Remember, questions are worth multiple marks. So you can see here with question 3, it's worth 3 marks. So even if you didn't get the final answer, you could get partial marks. So it's worth 3 marks. So, you know, for this question, and I'll explain it in a sec, you've got 2 points. So even just substituting them into your equation, you can get a mark. Okay, so just also do it what you can. All right, even if you think, oh, I don't know how to get the answer, just do what you can and you can get partial marks. All right, so this question here, what we've got is function y equals tan ax plus b, and we have to find the values of a and b. All right, so the other bits of information on here are just defining the function. They're not really relevant to the solution. So this just means it's continuous for x is between -1 and 1. So that just means there's no breakages in this tan function. And a is greater than 0, so we haven't had any reflections, sorry. And b is between 0 and 1. So when we think about our horizontal transformation, it's just going to be between 0 and 1, because tan graphs, as we know, can go on forever, but it's also, you can see these points here anyway. So that kind of helps you see that, well, that does make sense that a is greater than 0 and b is between 0 and 1. All right, we do use those 2 points to find a and b. So whenever you're given a function and you have to solve it, if you've got 1 unknown, you need 1 bit of information. 2 unknowns, 2 bits of information, and so on. So for this one, we've got 2 unknowns, the a and the b. So we need 2 bits of information, and they're the 2 points that are given to us. Sometimes you can see we've got asymptotes here, but we don't know the equations of the asymptotes, and we also can't see what this x-intercept is. All right, so that would help if we had that, but we don't, but we've got 2 points, so that's fine. So what we need to do first is just substitute in those 2 points. So I'm going to substitute in -1, -1 first. So we're going to have -1 equals tan -a plus b. Now there's no need to rearrange this equation because we're not looking at transformations. If we're going to solve it using transformations, we would need to take a out as a common factor, but we're not solving it that way. So we can just leave it as it is. All right, so let's get rid of that tan. So I'm going to take inverse tan of both sides. Actually, before I do that, just because what I'm going to do is just do -tan -a plus b equals 1, just because I prefer not to deal with the -1. And then I'm going to take inverse tan of both sides, but I'm going to leave that negative there. So inverse tan of 1. Now this is where you need to know your exact values. Now I know tan of 1 because it's my favorite one, pi on 4. Pi on 4 is the one I always remember. And what is that going to be? A plus A minus B. Whoops. Let's just move that closer to the equal sign. Yeah, A minus B. Okay, so we've got one equation. Let's do the other. Let's sub in the other point, and that is 1 root 3. Okay, so we've got the square root of 3 equals tan. 1 times A is A, so A plus B. And then just do inverse tan of both sides. We're going to have A plus B on, and then tan negative root 3. All right, I can't remember my exact value, so I'm going to quickly check. All right, so we've got pi on 3. So now we have our two equations, all right, in terms of A and B. So what we can do is say, well, A is equal to pi on 4 plus B. So I can then substitute that into here. So pi on 4 plus B. So I'm just substituting for A in my second equation. So this is A. And then I've got plus B equals pi on 3. And now I can just solve for B. So you can see what I've done so far is you're very close to getting 2 marks. Just substituting in those 2 points, 1 mark. Okay, so you can see you can easily get a point even if you struggle to go any further. All right, so let's tidy up. So 2b, and I'm going to take that pi on 4 over. All right, so I've got to have the same denominator. So we're going to have 4 pi on 12 minus 3 pi on 12. So 2b equals pi on 12. And then I'm going to divide by 2. So it's the same as multiplying by a half. So b is equal to pi on, 24. So if b is equal to pi on 24, then a is equal to pi on 4 plus pi on 24. Let's just get the same denominator. So 6 pi on 4 plus, 24 plus pi on 24. So a is equal to 7 pi on 24, and we can simplify, no, we can't simplify that any further. So I've got b equals pi on 24 and a equals 7 pi on 24. All right, so if you want to know the breakdown of the marks, and I'm just assuming here because I did not do the, didn't mark this exam. So you'd get obviously 3 marks for your final answer. You would get 1 mark for doing your substitution, which is great. So 1 here, and then getting 2 marks for getting your a plus b equals pi on 3 and a minus b equals pi on 4. All right, let's move on to the next question. So here we're at the 2019 exam 1. So we're going to be solving an equation here. All right, so when you're solving, it's important to note the domain. Okay, so we're not doing a general solution here, but we've got to find all the solutions between negative 2 pi and pi. All right, so with our equation, we've got 1 minus cos x on 2 equals cos x on 2. All right, so let's just bring the causes together. All right, so I'm going to have 1 equals cos x on 2 plus cos x on 2. Now I've got 2 lots of cos, so I can just say 1 equals 2 cos x on 2. All right, so when we've got 2 lots of the same thing, it's just 2 times it. All right, so what I can do now is divide both sides by 2, so that cancels out. So we've got cos x on 2 is equal to a half, and then x on 2 inverse cos of a half. So again, you should know your exact values I don't, so I just quickly did it on my calculator. All right, so we've got x on 2 equals pi on 3. So we've got to now take into consideration, because we're using pi on 3 as our basic angle, you can multiply both sides by 2, but we do need to take into consideration our domain. So x is between negative 2 pi and pi. So if we're looking at x on 2, we need to be looking between negative 2 pi on 2 and pi on 2 for our solutions. So effectively, we're going to be going from negative pi to pi on 2. All right, so let's get our unit circle out, as if I keep it in my pocket. All right, so negative pi is here, and pi on 2 is up here. All right, and then we've got 0 here. Now our solution, and I think I circled this before, so it might have just magically appeared before I edited my video. It's a half. It's a positive a half, so we're looking for solutions in the first and the last quadrant. Okay, so if we're starting at negative pi and we're going around the unit circle, keep going around, and we get to 0. So our first solution is going to be at x on 2 equals 0 minus pi on 3. And then our next solution, if we keep going around, is going to be at 0 plus pi on 3. And we're stopping at pi on 2. Okay, so I stop here. Now, remember, we've done quite a few of these. So I'm just going to tidy it up. So we've got negative pi on 3 and pi on 3. So to get rid of the 2, we multiply by a half. Oh, whoops. No, we don't. Why did I do that? We multiply by 2. All right, so we multiply everything by 2. So that means we're left with now x. So x equals negative 2 pi on 3 and 2 pi on 3 within that domain that we were given. Now this question was worth 2 marks. So you would probably get 1 mark for getting to, let me think, maybe here, and then 2 marks for both solutions. Okay, so just keep going, know your exact values. Okay, I know I use the calculator now, but you really need to learn them off by heart. So remember, stick them on your shower door or your toilet door so you can remember them. Or even on your laptop, you know, while you're bored in some other class, you can have a look at your exact values. All right, question B, the function f from negative 2 pi to pi, and this arrow r, hopefully you remember this notation, just means it can be any real value. F of x equals, so the domain isn't, any real, but we're looking at real numbers. All right, f of x equals cos x on 2 is shown below. Okay, so here's our function, our cos function. All right, let g equal, so we've got another function. Yeah. Oh, my computer's making that sound before it dies. Okay, so we've got this function here. So basically this g is going to be, now what do I have underneath? All right, so g is going to be 1 minus f of x, where f of x is given to us cos x on 2. All right, so we have to sketch G and label all points of intersection of the graphs F and G and the endpoints of G with their coordinates. So make sure you do that. All right, so what has happened here with this graph, if we think about the transformations, we've got this 1 and we've got this negative sign. So what has happened is that negative means it's been reflected and the 1 means it's gone, shifted up 1. All right, so with our points, so what we can do is take the points. We've got this point here, we've got this point here, which is quite easy to see, this point here, and this point here as well. Okay, so let's take the first point. We'll go from left to right. So negative 2 pi. Actually, let's start with x and y. So what is happening with them is it's been reflected. Okay, I should have said where. So reflected along the x-axis. Okay, so what that means is your y is now negative, and we've been shifted up by 1. So that means your y has gone up by 1, and your x stays the same. So the first point that we have is negative 2 pi 1. Oh, negative 1, sorry. All right, so I'm looking at this first point here. So that now becomes, your x stays the same, so it's still going to be negative 2 pi, but the y we multiply by negative 1. So negative 1 times negative 1 is 1, and then we add 1. So this now becomes 2. So negative 1, 1 plus 1 is 2. All right, so let's put that point in. So that point is now here. All right, next point, negative pi 0. All right, so your x's stay the same, which kind of makes it a bit easier. Negative 0 is still 0 plus 1, so that becomes 1. So we're going up to 1. And what's our next point? 0, 1. Okay, so the x stays the same. Negative 1 plus 1. Okay, so that goes to 0, 0. And then we've got pi 0. So it's going to become pi 0 plus 1. All right, so I just had to have a quick look before I did that. Okay, so we're going to just join our dots. Remember, it is a curve. So if you just go from one dot to the next, you should be fine. All right, so there's your function. All right, what we haven't done though, and probably poorly drawn, is look at these points of intersection. So this point here and this point here. And remember, we also had to put in the end point. So the end points are a little bit easier. So this point here is pi 1, and this point here is negative 2 pi 2. Okay, so make sure you do what the question asks. I just drew the graph and then I was like, oh yeah, I'm done. But we have to, and I even underlined it. So all points of intersection of the graphs F and G and the endpoints of G. Now, if we go back up to what we did in question A, you will notice we basically did those points of intersection. So what I have here, this is f of x. Whoops, it's a terrible highlighter. Come on, give me a little bit thicker. And this is g of x. All right, so g of x, f of x. And remember, when two graphs intersect each other, they are equal to each other. So we actually found those points of intersection in part 1. Now, if you don't remember, if you don't know how to do that, you can also see that our scale is going, actually I'll do it in here, we're going up by 3. So what we're going to have each time this is going to be pi on 3, 2 pi on 3, and then you got 3 pi on 3, and then you got negative pi on 3, negative 2 pi on 3, and negative 3 pi on 3. So this first point of intersection is negative 2 pi on 3, and we know that it's equal to a half. Okay, so you can kind of see that if you've drawn an awesome graph like me. And this point here is 2 pi on 3, a half. Now, if you didn't recognize that connection, you're going to be wasting time on your exam. But I think understanding that scale will help you easily find that point of intersection. Now, you notice that my drawing was probably should have intersected on that, well, it should have intersected on the line. That's just poor drawing on my part. But I wouldn't be penalized because it's pretty close, and I drew that dot there and I put the points of intersection. All right, so a lot of work for 2 marks, but I'm also talking a bit, so you need to work quickly. All right, next question is from the 2018 exam 1. All right, so with this question, we've got, we're solving again. And I feel like Word might die on me very soon, which is going to be annoying. Okay, so here's our equation. Okay, so we don't have anything to do with f of x just yet. And here's our, oh, yes, we do. We're just letting it equal 0. So basically we're finding the x-intercepts. Okay, so what we need to do when we're solving is find the reference angle first, or the basic angle. All right, so I'm going to take that 1 over as -1, and then we're dividing by 2. So we've got cos x equals -1/2. So x is equal to inverse cos of -1/2. Now, you only need the reference angle, so don't worry too much about that negative for the reference angle. So your reference angle is cos -1/2. Now, we did that before, and I can't remember what it was. Let me just scroll up. What was it? Pi on 3. Okay, so it's pi on 3 is your reference angle. Now, to find your other solutions, I would quickly draw the unit circle. We're going from 0 to 2 pi, so 0 pi, 2 pi, which is nice, doesn't want to confuse us. And we're looking for cos where it's negative, because this is negative. So cos is negative in the second and the third quadrant. So our solutions, if I go back here, we're going to have x equals, now it's great that we're only looking at x, okay? Here in the previous one, we're doing x on 2. In other questions, we've done 2x, it's just x, which is nice. Okay, so we've got pi minus our reference angle and pi plus our reference angle. Now, we don't have any other solutions because we only want to go from 0 to 2 pi. So let's just tidy that up. So we're going to have 3 pi on 3 minus pi on 3, and then 3 pi on 3 plus pi on 3. So 2 pi on 3 and 4 pi on 3. So not a tricky question. That if you got a question like that, you should be ecstatic. That should be one of your first questions. Easy peasy Japanesey. Okay, don't glitch on me. Question B, sketch the graph of the function f on the axis below, label the endpoints and local minimum point with their coordinates. All right, so let's just highlight so we don't forget, like I did in the previous question, everything that we have to label. So label, oh my gosh, I'm going to have to restart. All right, now I've just restarted Word, so hopefully it doesn't glitch on me. All right, so we need to label endpoints, local minimum points with their coordinates. And we should also put in the x-intercept. So what might be a good idea is whatever it's asking, just put it on the side here. So we need endpoints, and we want the local minimum. All right, and then we can also do the x-intercepts, which isn't too hard. So then you've got a checklist. At the end of the question, you can just go, yep, yep, yep. Okay, so let's not tick them yet because I haven't done them. Okay. All right, so what we did in question A is we actually found the x-intercepts because we let the function equal 0. So 2 pi on 3 and 4 pi on 3. So our two x-intercepts here and 4 pi on 3 is here. Now, what else have we got? So we've got 2x, 2 cos x plus 1. All right, I'm going to have to write it down here. All right, so we've got an amplitude of 2. So basically our original graph has gone from -2 to 2. But because we're shifted up 1, we got to go up 1, and this has got to go up 1. So now our range is going to go from -2 plus 1 is -1, and 2 plus 1 is 3. Whoops. Should be a square bracket because these values are included. Now, it doesn't say that we have to do the range, but that is going to help us. So we're going from -1 to 3. All right. If you want, you can always just put a faint line, which is very hard to see, but just so you know what to do. Okay, and now with your sine graph, actually, before we move on, sine and cosine graphs also have a line of symmetry. So our line of symmetry is just going to be through y equals 1. So if you think of your basic cosine or sine graph, before it's shifted up or down, it just, your line of symmetry going through the middle is your x-axis. So if we're shifted up by 1, that's now going up 1. All right, so cosine graphs, this one hasn't shifted left or right, so we're going to be starting at 3. So I might do this in green. All right, it does have to go through 2 pi on 3, and there's going to be our minimum, okay, because it is symmetrical, and we're going to end here. Now, if you're wondering what our other points are, okay, the pi on 3 does help us. Let me just think. Okay, there and there. So if you think of a basic cosine graph, if we were just to do cos x, just goes like this. All right, so that's basically what we're going to be drawing here. If I can go through my points correctly. There we go. Didn't really hit that bottom point, but that's okay. All right, so this, remember, we've got to tick off. So our end points we need to label. So this point here, even though we can clearly see that it's 0, 3, we need to label it. So 0, 3, and our other end point is 2 pi 3. Took me a while. And then, so we've done that. Great. And didn't ask us to do the x-intercepts, so I'm not going to do them. And the local minimum is pi -1. So let's just check, because it's a 3-mark question. So you want to get as many marks as you can, because the sketching graphs isn't that difficult. Sketch the graph, done. Label the endpoints, done. And local point with their coordinates, all done. All right, so great if you got a question like that one. Easy 5 marks. All right, let's move on to the 2017 exam 1. All right, so this one here is quite a difficult question, and it looks difficult. But if you think of this as just maybe a quadratic, so remember the null factor law. So basically we've got 3 brackets here, and multiplying them together equals 0. So that must mean one of those brackets has to equal 0. Okay, so what we might first of all do is say, well, we can get rid of, let's call them bracket 1, bracket 2, bracket 3. Okay, so if we divided through by bracket 2 and 3, we're left with tan theta minus 1 equals 0. Okay, so I'm dividing through by, so if I divided through by bracket 3, 0 divided by that bracket is still 0. If I divided through by bracket 2, 0 divided by bracket 2 is still 0. So I can have tan theta minus 1 equals 0. I can have that second bracket. All right, so we're looking for possible values. So that's an indication that we might have more than one solution. Whoops. Equals 0. And then the third bracket. So just think of your null factor law when you're solving quadratics. All right, so let's go to the first one. So tan theta minus 1 equals 0. So remember, we're looking for solutions of tan theta. So all we need to do is get tan theta equals. So for the first one, tan theta is equal to 1. For the second one, this is where you need to know the relationship between sine, cos, and tan. So tan theta is equal to sine theta over cos theta. Oops. So for this one, what I can do is I might just put the root 3 cos theta onto the right hand side. All right, so just adding root 3 cos theta to both sides and then divide both sides by cos theta. So sine over cos, remember, is tan. And cos over cos is 1, so that cancels out. So tan theta is equal to root 3. And then we do the similar one to the last bracket. So we can have sine theta equals negative root 3 cos theta. Divide both sides by cos theta. So sine over cos is tan theta. And then they cancel out and we've got negative root 3. So we've got the 3 solutions. So tan theta equals 1, tan theta equals root 3, and tan theta equals negative root 3. A lot of work for 1 mark, which was quite frustrating. Anyway, hence find all possible solutions for tan theta minus 1 times sine squared theta minus 3 cos theta equals 0. For theta is between 0 to pi. All right, so so this is the same function as above. It's only that this has been written factorized, this. Okay, so if you were to, that's the expand, hold on, if you were to expand this first bracket, which I think doesn't really come up too well, if we were to expand that first bracket, we would get that function in pink below. Okay, so expanding this in yellow would give us what we've got here in pink. So basically, we take the 3 solutions from the previous question and we're just solving for theta. Now, theta has to be between 0 and pi. So tan theta is equal to 1. So theta is equal to inverse tan of 1. Now, that's the one I know, which is pi on 4. All right, another solution, tan theta equals root 3. So theta is equal to inverse tan of root 3. Now, we did do one of these earlier, didn't we? What was that, pi on 3 from memory? I might just check. All right, yep. And the last one, we've got tan theta equals negative root 3. So theta equals inverse tan of negative root 3. So if we just look at our unit circle, just quickly, so we want it to be negative. So first of all, we're going from 0 to pi. Tan is only negative here. So our solution is going to be pi minus pi on 3 because we're in this quadrant. So that's going to be 2 pi on 3. So we've got our 3 solutions. We don't have to rewrite them again. You can just put a little square around them, like so. All right, moving on to 2016. Okay, so this time we've got an average rate of change question. So we didn't spend a lot of time doing the average rate of change, but basically the average rate of change is just the gradient between 2 points. Okay, so if you think about drawing a straight line between x equals pi on 3 and x equals pi on 6, it's just the gradient of that line is your average rate of change. Okay, so let's first of all substitute in negative pi on 3, 2 sine 2 times negative pi on 3. And don't forget that minus 1. Oh gosh. You know, I feel like questions like this, you might rush and forget that minus 1. All right, and then we'll also substitute in the pi on 6. 2 sine 2 times pi on 6, and don't forget that minus 1 on the end. Okay. My son is messaging me asking me to get his ice cream for him. Okay. Negative 2 pi on 3 minus 1. All right, so what we need to do is with the negative 2 pi on 3, we do need to have a reference angle. So this is the same as 0 minus pi on 3. All right, so you need a reference angle like pi on 3, pi on 6, pi on 4, and you need to go from either 0, pi, 2 pi, whatever. All right, minus 1. So our reference angle, let's just do that on the side. So sine of pi on 3. Now I don't know what that is, so I'm going to have a sneaky look. All right, so it's root 3 on 2. So I'm going to keep going. Oh, son keeps asking me for an ice cream. All right, so we've got 2 times now root 3 on 2 minus 1. All right, sorry, we should have that as a negative because we're looking at sign in the negative. So 2 times negative root 3 minus 1. So those 2's actually cancel out. So we've got negative root 3 minus 1. All right, now substitute in pi on 6. So we've got 2 sine, I've already done that. So pi on 3, oh, that's a bit easier, isn't it? So we did that before. 2 times root 3 on 2. This time it is positive, so they cancel out. So we've got root 3 minus 1. Now your average rate of change is we're looking at 2 points. Okay, so our first point is at x equals pi on 3. So that's your x coordinate, and your y coordinate is negative root 3 minus 1. And your other point, the x coordinate is pi on 6. And your y coordinate is root 3 minus 1. So remember with your gradient, it's the average rate of change. So average rate of change is equal to y2 minus y1 over x2 minus x1. So you can call this x1, y1, x2, y2. And we just substitute that in. So y2 is root 3 minus 1. And then we're going to subtract. Now just lots of negatives, so don't get your negatives mixed up. Over x2 minus x1. So I'm going to have them as the same denominator. So I'm going to rewrite that negative pi on 3 as 2 pi on 6. I'll give you enough space. All right, so root 3 minus negative root 3, so 2 root 3. Negative 1 plus 1 is 0. And then we've got pi on 6 plus 2 pi on 6, so 3 pi on 6, which is pi on 2. Now we shouldn't leave it like that. So it's 2 root 3 times 2 on pi, and that will give us 4 root 3 on pi. All right, so that question was worth 2 marks, I think. Let me just go back up. So 1 mark would come from doing the substitution, and then your other mark would come from doing your rate of change. So getting your final answer. So there's your second mark and your first mark doing your substitution. So make sure you know your exact values, okay, because you need to know your exact values to do that. All right, so part B, calculate the average value of f over the interval pi on 3. X is greater than or equal to negative pi on 3 and less than pi on 6. All right, so with average value, we didn't really cover it in class, so it will be coming up in a video. But your average value is quite easy, but you can't get it mixed up with the average rate of change. Okay, so average value is different to average rate of change. And now I'm just going to go to the textbook. So here is the average value formula. All right, so 1 over b minus a, and then you're just doing the definite integral from a to b. All right, so let's put that on here. And it's not on your formula sheet. So I did a quick check to see if it was on your formula sheet, and it isn't. So we're going from a to b, f of x dx. So let me just double check I've written that down correctly. Looks good. All right, so remember your lower limit is a and your upper limit is b. So we're going to have 1 over b, which is pi on 6, minus a, which is negative pi on 3. So just be careful with those two negatives. And we're going from negative pi on 3 up to pi on 6. And our function, what were we working with? 2 sine 2x minus 1. Make sure I've written that correctly. Awesome. All right, so we've got out the front pi on 6 plus 2 pi on 6, so 3 pi on 6, so pi on 2. And what we've already, I should put the dx there, whoops. What we've already done is we've substituted in negative pi on 3 and pi on 6 already, so it's not going to be too hard. Oh, actually, no. What am I talking about? We've got to find the antiderivative. That's my fault. So pi on 3 to pi on 6. All right, so finding the antiderivative of 2 sine 2x. All right, so the antiderivative of sine is negative cos. So we're going to have negative 2 cos 2x, and the coefficient of x we're dividing through by, and then minus 1, the antiderivative of any constant is just x, so we're going to have minus x. Now those 2's will cancel out, so let's just tidy things up before we do our substitution. So 1 divided by pi on 2 becomes 2 on pi, and then we've got negative cos 2x minus x. How much room have they given us? All right, and we're going pi on 6, negative pi on 3. All right, so let's substitute in pi on 6 first. So we can put the 2 on pi here. Negative cos 2 times pi on 6 gives us pi on 3, minus pi on 6, minus. All right, so we've got the first substitution and then we've got the second substitution. So we're going to have negative cos negative 2 pi on 3 minus negative pi on 3. All right, so let's just tidy things up. So we've got to keep the 2 on pi out the front. Cos pi on 3, oh, again, don't know my exact values. All right, so it's a negative half minus pi on 6. Now, I'm just going to put brackets, big brackets around, minus, all right, so we've got negative cos. This is going to be 0 minus pi on 3 plus pi on 3. So much work. Okay, let's keep going. I'm going to keep that first bracket as it is and hope that we can start cancelling some stuff out. All right, so cos pi on 3, we know is half, and negative, so we're going to be, cos is also going to be positive, so it's going to be negative pi on 3. No, not pi on 3, half. Oops. So the negative stays, but we are in the fourth quadrant where cos is positive, so it's positive a half plus pi on 3. Oh, this is where it gets frustrating. Okay, so we'll keep the 2 on pi out the front, and let's just do negative a half minus pi on 6 plus a half minus pi on 3. All right, so those halves cancel out, which is awesome. So we're left with 2 on pi times negative pi on 6 minus pi on 3, which is 2 on pi times. All right, so negative pi on 6, so negative pi on 2. Oh, is it going to be negative 1? I don't, let's just check. All right, so my answer is wrong. So I'm going to go back and just check. Now, obviously you can't do this in an exam. And I probably wouldn't in an exam just because you're so short on time. But this is why it's important to take your time, and I thought I did. So this is correct. All right, let's go through my substitution. So 2 on pi, negative cos, so substituting in pi on 6 gives me pi on 3, minus pi on 6, awesome, minus negative cos minus 2 pi on 3, good, minus negative pi on 3. Okay. So cos pi on 3 is a half, so negative a half minus pi on 6, good. And then cos negative pi on, okay, so negative 2 pi on 3 is 0 minus pi on 3. No, that's where I made my mistake. It's not 0. Oopsie, oopsie. It's pi minus pi on 3. So that must make a difference to our unit circle, because pi minus pi on 3, we are here where cos is negative. So this should be now a plus half. Okay, so let's just double fix these. So we're going to have minus a half here. I think the rest is correct. So they don't cancel out. So let's just tidy all this up. All right. So we've got negative a half minus a half is negative 1. And then negative pi on 6 minus pi on 3. So that's going to be negative pi on 2. So we're going to have negative 2 on pi minus 1. All right, great. And that's my solution. So my error came from this part here. All right, so I obviously would never pick that up in an exam, but I would have got 2 out of 3 marks, which is nice. But, you know, making those small errors during your revision is good, because then hopefully you won't make them in the exam. All right, do put when you've got a lot of working out here, especially in exam 1, do put a little square out around your final answer, just to make it easier for the person to see. All right, now I don't know how many more. Oh, we've got a lot of questions to get through. How many exam 1s? Oh, quite a few. And then we get into some exam 2s. All right, so this video is already very long. Let's just go back. Oh. I'm glitching. Oh, yeah, 2015. All right, so now we're getting into the previous study design, but we should still be seeing the same course content for circular functions. This question here, it's an application style question, but we still have to do it without a calculator and without a bound reference. All right, so question 5. On any given day, the depth of water in a river is modeled by the function. So got this, and very similar to your SAC questions or SAC style questions. So H is the depth of the water and T is time. After 6 a.m., very important. All right, so we're going from 6 a.m. one day to 6 a.m. the following day. Find the minimum depth of the water in the river. Okay, so we need to consider the amplitude. So the amplitude, we're going from -8 to 8, all right? But the range, we're going to be adding 14, okay? So we've got 14 here, so we're going to add 14 to both of them. So your range is going to be -8 plus 14 is +6. And 8 plus 14 is 22. All right, so the minimum depth of the river is, what is it, in meters? 6 meters. And the maximum depth is 22 meters. All right, part B, find the values of T for which HT equals 10. All right, so let's substitute in 10 for HT. So we've got 10 equals 14 plus 8 sine pi t on 12. And we're just going to solve for t. So I'm going to bring that sign over. So 8 sine pi t on 12. And 10 minus 14 is -4. Divide both sides by 8. It's going to give us -4 on 8, which is -1/2. And then we're going to take inverse sine of both sides. All right, so we've got pi t on 12, and inverse sine of 1/2 is pi on 6. And because it is negative, we do need to take into consideration that. So pi on 6 is our base angle or our reference angle. And we need to use the unit circle to work out where sine is negative. So sine is negative in the 3rd and the 4th quadrant. So our solutions, we're going to have pi t on 12 is equal to, first of all, pi plus pi on 6. And then we're going to have 2 pi minus pi on 6. Now, we are only looking at a 24-hour period and we're looking at the depth of the water. So you think of tides, they kind of only happen twice. So I'm just going to leave it at the 2 solutions, but we just need to tidy it up. So we're going to have pi plus pi on 6 is 7 pi on 6, and then 2 pi minus pi on 6 is 11 pi on 6. All right, so let's get rid of that 12. So we'll multiply everything by 12, so they cancel out. All right, so that goes. So I'm left with pi t. Okay, so the 12 on 6 becomes 2, so I'm going to have 14 pi, and then 22 pi. Divide both sides by pi, just to get t on its own. So t is equal to 14 and t is equal to 22. Now, it doesn't ask for the time, only values of t, so I don't have to interpret that, but remember t is hours after 6 a.m, so I would have to work out what that would be. So that would be 8 p.m. and 4 a.m. But we don't have to do that. All right, I'm going to leave the video here because it's quite a long one, and I'll do a separate video for the other questions, maybe a few more videos. All right, thanks girls, bye.